have the pleasure of introducing Dr. Dan Cohan. He was a Texas delegate in '94, and then Texas, yeah. So then he was on staff for the next 3 years, and then this is his first time back, and it's his first time lecturing. So we gotta make sure we give him like enough support that he wants to come back again and again. Went to Harvard for undergrad, and then he had a Fulbright year in Australia, and he did some really cool work, so you should definitely ask him about it. He got his PhD at Georgia Tech in atmospheric science, but it was at Georgia Tech that he started getting interested in environmental engineering and worked with a professor in that. He's currently a professor at Rice, and he really likes to live in Texas, so he's back living in Texas because a lot of his family moved back, and so there's a lot of them there, and they get to see each other a lot. So he said that his favorite place that he's lived is Melbourne, and that was part of his Fulbright year in Australia, so that's pretty cool. You should definitely, like I said, ask him about that. He's currently writing a book, and he said that it's given him a chance to meet a lot of really cool people and explore lots of different cool things, so you should keep an eye out for when his book comes. And then I asked him, I had to ask a fun question, and we all like Mothman here, right? And when I asked where he thought Mothman lived, he told me he didn't know who Mothman was. But it's okay, because I asked him whether he liked cake or pie better, and he said ice cream pie. Yeah. So if you ever want to make him a birthday present, he really likes ice cream pies, and you should send him one. But if he's making the dessert, then he makes a really good berry cobbler, so with his grandma's recipe. So without further ado, please help me welcome Dr. Dan Cohan.
Grandmother with the cobbler recipe was famous in my years at camp because she would send these care packages with homemade cookies and favorites here. So yeah, missed her a lot. She and my grandfather met at Rice, so it's been really special these 13 years being back teaching at Rice, and very special being here with you. Something I'd always dreamed of coming for, but always forgot each year to see about making it happen. So finally here I am. Where's the clicker? Okay, so what I'll be talking about is which of these worlds are we going to be living in? What can we do to be in that path on the bottom, which really is in our own hands? What we do in your lifetimes is going to determine if we're in that path along the bottom where we have emissions coming down very quickly, and if we do, we can have warming that's already been warming up that could level off pretty soon, or are we going to be on one of those high paths that mean much warmer temperatures? And it's really the choices that we make in your lifetimes, and even especially choices that we make in the next 10 or 20 years that are going to be pivotal in determining that. But first, a little bit about myself. I've seen a number of presenters sort of give their own story, because I think part of what you're doing is not just learning about our research or the science, but who we are, and maybe getting some points from there. So really, I think it's important to thank the influencers who shaped us early on. So of course, parents, and I was really fortunate even going to just neighborhood Dallas public schools, that there were a few teachers along the way who really shaped my interests. That there was a middle school teacher who said we could pick any topic that we wanted, 7th grade, and it just so happened that that was when it was just after the summer that Washington, D.C. had its hottest summer in history in 1988, and Jim Sanson from NASA had gone to Congress. Someone turned off the air conditioning, and all sweating, he told Congress that he knew that human activity was warming the planet. And so global warming really got into the news. 1988, I think, ranked maybe 15th or 16th hottest. Now we've been way hotter since then, but it seemed really hot at the time. And so when I could pick any topic in the world to study, I chose global warming as a 7th grader. In some ways, I've never stopped studying it. And she really pushed to independent research and problem solving. Does future problem solving still exist? So that's something that it does. So that's something that she got us to do and coached us to winning the international with that. And then there were 2 math teachers in middle school and high school who really pushed me along the way. And at our regular neighborhood school, we had a journalism teacher who was the National Journalism Teacher of the Year. And so he turned our school newspaper into a consistent national pacemaker. So I learned to write, I learned math, learned problem solving. Notice there's no science teacher on here. We didn't have any decent AP science courses. Science was really boring at my school. And then science camp came along, and I finally saw that science could be cool. So instead of heading to Harvard wanting some way to use math and assuming that meant I needed to be an economics major, I found that, hey, there are lots of other things. I don't know which of these things that these dozens of presenters are getting me excited about, but I want to go see if there's something that I could be excited about. And so science, and I put passion here too. And I know Dr. Wilson told us about the crushes that everyone's having on each other. I'll confess that I was guilty of one of those back in the day, but that went nowhere, of course. Like most of yours will end up. Sorry for the downer. But by passion, what I mean isn't romantic, but just from the fellow delegates, just amazing people who all came with different talents and got to know what those were. From the lecturers who came in, from the staff, really picked up that it's important to feel that passion for what you're doing, whether it's for science, whether it's for music, and really special to have Woody here, who is the only one who's ever let me sing, as out of tune as I am. Art, so people find their passion here and just realize, don't let that be a science camp special thing. The outdoors, the science, getting to know people, they're really special people wherever you go. So don't think that the outdoors is only this month of your life, or that these really amazing people, that you can't have those kind of connections with the people you meet beyond. So figure out what it's going to mean that you're going to take science camp with you beyond this place. Then got into the actual bulk of what I do, because wanted to find some way to look at science. And so as a freshman, I was looking for an elective. Instead of taking something like a normal elective would be, I decided to take atmospheric chemistry. It was the only freshman in Professor Jacobs' class. I asked him early on, hey, is there some way I could do research? It was rekindling that middle school research. He said, he kind of brushed me aside. And I did well in his course, and he said, hey, would you ever think about doing research for me? I was like, did you forget that I asked if I could do research for you? But I ended up doing research for him all 3 remaining years of college. Worked with some data that he got. He led these NASA flight campaigns over the tropical Pacific, so he was studying very clean air. He helped me get the opportunity to go to Australia, where I kept studying clean air at what's called a baseline air monitoring station on the tip of Tasmania, at a place called Cape Grim. And then when I got to Georgia Tech, there was lots of dirty air in Atlanta. Realized, hey, it's really cool scientifically to study that very clean air coming off the Southern Ocean or off the tropical Pacific. But my interest has always been, what can we do about it? That problem solving that I picked up in middle school is, how is this going to make a difference in people's lives, what we do? And so I decided that I'm not going to do anything to control things coming out of marine life in the Pacific or the Southern Ocean. I want to figure what we do to clean up air pollution. So it was Professor Ted Russell who got me along that direction. Just have to stand here and this work. So then I took a policy turn. Instead of doing a traditional postdoc coming out, I went to work for the Georgia Environmental Protection Division, where those of you who think that the only path in science has to be academia or national labs, make you aware there are positions, state, local governments, smaller places that you don't think about as much, where a PhD goes a long way, where you're not surrounded by everyone being a PhD, but coming in with a PhD fresh out of grad school was able to be helping to write the mercury and the ozone and PM policies for the state, because it helps you stand out when other people don't have that sort of background. And then at Rice, very thankful for some federal agencies that took a chance on my work and helped it really get started, EPA, NSF, and NASA. Then I got tenure, and the dean says to me, okay, congratulations, now what are you actually going to do with your career? And so kept doing most of the same things for a while, and still am continuing the research in atmospheric science and now starting to look at how soil and agriculture systems affect the atmosphere, but decided, hey, I used to be able to write English. I used to have a journalism teacher who said, you need to write clearly. How do I go back and do that again? So got a gig where I started writing a column for The Hill, writing for The Conversation, Houston Chronicle, other things, and have been writing in English again, things that people actually can read and understand beyond my technical field. And so that's where I said, okay, well, what's the next step? And for the past couple of years have been beginning to work on this book and just got the contract last week. So it's starting to feel like a reality. So enough about me. Let's get to the substance of what I wanted to talk about. And that's what I'll call solving the climate challenge. So we'll talk first, and I'll usually use red to sort of highlight the problem. So what is the problem with climate change? The trends, the causes, and the impacts. And then we'll talk about what are the solutions. And I'll just take the title and the theme of the book that I'm starting to work on, and I'm going to argue to you that there are 3 keys that it will take to unlock the gridlock that we have that's keeping us from addressing climate change. That we need diplomacy, we need technology, and we need policy. And I'm really focused on the U.S. All my work has been on the U.S., so other people can definitely look elsewhere, but I'm really looking, what do we do to address this gridlock in the U.S.? But I will try to convince you that if we can address our own problem in the U.S., that's going to leverage as a necessary but not sufficient step to really deal with this globally. So I'll have this in sections. You'll see at the end of each section, I'll open it up for questions. I've had the opportunity while I'm doing directed study and really appreciate the enthusiasm of the directed study students. Try to mix things up. My own personal preference is that I usually don't lecture straight as long as 75 minutes. So we'll work into questions in each block. And the other thing I've observed is I've seen a lot of the same people asking questions. I've seen a lot more women than men or campers, but I'm seeing less questions. So I'll first ask for women or people who haven't been asking questions the first few days, if you would ask questions first. And if you have already asked a question, if you could give other people a chance. I know we have 100 people here, and I know a lot of you will have questions, so I want to be sure everyone gets heard from. So anyway, I'll make up my own rules. I've got the stage. So what is the problem? And could speak for hours about all the problems, but just the basics of what we face is that we've already warmed by 1 degree Celsius, or nearly 2 degrees Fahrenheit, from where we were pre-industrial. And you can argue around the edges about exactly what was pre-industrial, but I think Berkeley does a pretty nice job in this plot of showing it, and point out that when we're saying it's 1 degree Celsius, or almost 2 degrees Fahrenheit globally, how many of you live over land? Okay, so you're experiencing more warming than this. Okay, unless you're a yacht owner, you're living in this world where it's already warmed nearly 2 degrees Celsius, or about 3.6 degrees Fahrenheit, above where it was in the 1800s. And this is something that I really didn't come across. This plot, it's pieced together from 2 studies in Science magazine. And really this has hit home to me more than ever of just how profound it would be, the potential change we could have by the end of the century. Is that in the depths of the last ice age, so think woolly mammoths and giant sloths and glaciers in this completely different world than we were in today, the depths of the last ice age before we started emerging from that last glacial maximum was only 3 or 4 degrees Celsius colder than it was in the pre-industrial times. Those who are interested in some details, they actually had a Holocene maximum. We had cooled off into a little ice age that's often taken as the baseline for our pre-industrial. We've warmed up about 1 degree Celsius since then, and most estimates say that a business as usual case, if everyone follows through what they said they would do for the Paris Agreement, we're going to be about 3 to 3.2 degrees Celsius above pre-industrial levels by 2100, and we're not going to stop there. Okay, we're not going to stop warming until we get to what I'll call net zero, that I'll explain later, but that means that this is like a cliff that we're about to be climbing up, that we're already starting to climb up, and so that difference from where a few generations ago we're at to where we are in the future is going to be about the same gap as what that was, what those pre-industrial times were versus the ice age. And just if that doesn't hit home enough to you how much different that is, this is how different the world was in the Ice Age. Okay, so 3 or 4 degrees doesn't sound like much because we live in a Fahrenheit world, we live on land, we don't realize how much things have changed. But, okay, any delegates from Washington State, North Dakota, Montana, okay, down to Illinois, all the way into Iowa, right about down to Manhattan, all the way up to New England, that was an ice sheet. That's not where the snow was in the winter. That's an ice sheet that covering Canada was 2 miles thick. Okay, higher than any mountain in West Virginia, so totally changed the weather patterns, the wind patterns of the Earth. It took just that 4 degrees was enough to melt almost all of this ice, okay, going across parts of Europe and Russia. And that's why the seas are now about 30 meters higher than they were. That took centuries, it took millennia to get the sea level to rise that much, to melt this much ice. Fortunately, we don't have this much ice sheet left to melt. Okay, now it's going to be Greenland and Antarctica that will be coming next. But just showing its profound changes in virtually every ecosystem on Earth that happens with what sounds like just a small single-digit change in temperature. So really, I want to be sure that hits home. And part of the reason is that different parts of the world warm faster than others. And this is showing just the change that's happened since, since the beginning of my lifetime. Is that the Arctic has been warming faster than everywhere else, the land has been warming faster than everywhere else. Part of this is because the sea ice is melting. We have about half as much sea ice as we did a few decades ago, so that sea ice is no longer bouncing sunlight up into space. It's leaving warm waters behind that soak up more heat. It's leaving warm land behind that can soak up more sunlight as the land glaciers melt. And so you're in Alaska delegates here, you've been experiencing climate change in real time several times faster than the rest of the planet. Okay, so I promised I would break things up into talks, so who has some questions about trends in warming, especially either the questions you've had or when you hear people say, oh, this is all a hoax, okay, people are making this up, is there anything that you don't know how to answer when you get those questions? So what questions do you have at this stage?
How did they get the data from 4,000 years ago? What, the geological data?
The geological data.
Temperature 4,000 BC.
Yeah, it's proxies that they take, piecing together evidence from ice cores, from tree rings, from coral growth, and so it's a Marcotte study in science that I could point you to where they took all the proxies together, and there's definitely uncertainty in it, but that's the best estimates they can get from variety things. Yeah.
If we do fix the global warming, will it just taper off and become like a plateau, or is there a way to decrease it and like freeze some more ice, or fix it?
Right. So if we could stop global warming, do things stop there? So it comes in a series of steps. First, we just have to have emissions peak. Emissions are still going up, as you're going to see in a minute. Then emissions, of course, need to come down, and then they actually need to fall all the way to where we're removing as fast, either our activities or natural things, or removing them as fast as we are putting them up. And so then you'll get, say, CO2 and other greenhouse gases to be stabilized. Then it'll take time for the climate to equilibrate to that. You're going to have still another few tenths of a degree as the temperatures catch up with that. It's going to take a lot longer for the oceans and for the ice to catch up with that warmth. So unfortunately, the melting that we're seeing so far, the changes in oceans so far, that's nowhere near what's going to happen. Is that it's going to be centuries because we've already warmed up one, and as we catch up to what's in the air, we're going to be at nearly 1.5 degrees Celsius warming. So it's really going to be, centuries and centuries, if not millennia, where ice is going to keep melting, and we're going to keep having changes in the world as we catch up with that temperature. Hopefully we can stop it there, and it's not 3 or 4 degrees that then is going to change things even more. But it's probably been enough that we've probably staved off the next several ice ages. We would probably naturally be heading into an ice age, and we've already staved off the next several. Yeah?
At what point is this going to become like catastrophic, like people are dying every day because of this? Like how many degrees of warming would that be?
Yeah, I mean, it's a matter of increases that we've already seen impacts where people are being affected by the warming today. Is that storms are already being stronger, droughts are already being stronger. There's arguments that some of the droughts that help trigger the Syria civil war. So you could argue that there are already deaths and hunger and things that are being caused by climate change. And yeah, it grows as the warming question is, as we lower emissions, will the weather settle back down? So just lower, I'll show that in a bit, just lowering emissions, temperatures will keep going up. You have to go all the way to a balance with removal before temperature stabilizes. Once the temperature stabilizes, then the weather will stay about the same. Yeah, ice will keep melting, but the weather will sort of get to a new normal. It'll become a new normal. It won't be, you won't have the weather that your great-grandparents had, but the weather will stabilize. Other things like ice and forests, things that take a long time to adjust, they are going to keep changing. Yeah, let's take one more question now, and then I'll.
Yeah, so what causes like non-human based like global temperature changes? Like what causes the ice age?
That's coming up.
Okay.
Yep, great. Yeah, so I want to get to solutions, so want to be sure we get through some of these parts quickly. Okay, so I hope I've convinced you that it's warming, and I could give you 100 other pieces of evidence that it's warming. But if it is warming, so if there is some damage going on, okay, there is a Mr. Body, a crime is happening, who's the culprit? Okay, so is it Colonel Mustard in the billiard room with the candlestick, or what's going on that causes this? Normally, and so this addresses the question that came up, is what normally causes this to happen is we've been having ice ages and warm periods forever. Okay, the world's climate has always been changing. This gets used by denialists to say, oh, well, it couldn't be human caused now because humans weren't there, and we've had, this is just the most recent 800,000 years, and there's been sort of a steady pulse of ice ages and warm periods, so it couldn't be us now. Okay, that's like tobacco companies telling you that people had cancer before they started making cigarettes, so it couldn't be cigarettes causing cancer today. So indeed, there are natural things that cause warming, just like there are natural things that cause cancer. And when we've had these cycles before, the driver that kicked it off is orbital cycles. And so the orbital cycles are shown here, is that there are three aspects to the way that the Earth goes around the sun, and hopefully you all know how it goes around the sun. No flat earthers here. And so how eccentric the Earth's orbit is, how elliptical it is versus how circular, that changes over 100,000 years' time. When we're more circular, we on average get more sunlight than if we're elliptical. Okay? So that's going to change things. How oblique we are, how the tilt that you probably learned, I think it's what, 23.5 degrees? Now that tilt changes over the course of tens of thousands of years as our orbit sort of wobbles. Think of it like a top that wobbles as it spins around. The other thing that changes is since we are in an elliptical orbit, when are we closest to the sun? So hopefully you realize that when it's summer, here is when our axis is pointing towards the sun, and as we go around and the southern hemisphere is more pointed towards the sun, this is our summer, this is our winter. But when are we actually closest to the sun? So how many people think it's during like our winter? So December, January, February, we're closest to the sun. How many think it's in the spring? March, April, May. How many think it's during our summer? June, July, August. Okay, so I'm impressed. So most people actually realize it's during our winter. It's actually January when we are closest to the sun. That is what should be pushing us into the early stages of the next ice age. Okay, because when we are closest to the sun in January, that means we're farthest from the sun in July. The northern hemisphere is what's most sensitive to that, because we have Arctic sea ice that's really variable, and we have glaciers over land that are very variable. When it's sunny, if we were closer to the sun, those could melt, do that feedback cycle of soaking up that heat, and we could, since we're farther from the sun, we would have less warm summers, we would have less melt. That should be driving us into a natural, beginning stages of a natural ice age. There's debate about how strong that might be, but it would tend to be a cooling phase right now. So that changes about every 20,000 years. So that is what kicks off the cycles. And if you look these cycles, this is the tropical temperatures. Tropical temperatures only vary about 2 degrees Celsius between ice ages and warm periods. This is the Antarctic temperatures. They vary more like 8 degrees Celsius between ice ages and warm periods. And you'll notice that CO2 is virtually in lockstep with temperature. Can't even really tell whether one goes up before the other. And so what is happening is that the orbital cycle kicks it off. So we move to an orbital phase that gives us more light on average, more sun. That melts permafrost, which releases CO2 and methane. That makes respiration happen faster, which releases it. It makes the oceans warmer. And just like your warm Coke releases its carbonation, that releases carbon dioxide into the air. So all these things, as it gets warmer, feed upon themselves to make it warmer. The warmer air holds more water vapor. Water vapor is our most abundant greenhouse gas. That makes it warmer. That melts more ice, which makes it darker. So these orbital cycles should only give us half a degree or so of warming, but they end up giving us 4 or 5 degrees of warming because it feeds back upon CO2, ice feedbacks, water vapor feedbacks, all these other things in these natural pulses. And sea levels, as you see, usually change by 50 to 100 meters between these cold and these warm periods. Enormous changes in sea level, but those, it's hard to tell because this is an 800,000 year plot, but these take many thousands of years for these changes to happen. We also have other natural things. So here I've just got about 100 something year cycle. So the shorter term variation, the little bitty ups and down in temperature, most of those come from 2 things that, in a natural way. Volcanoes. So the last time we had a really major volcano was Pinatubo. We had El Chicho in there. And you see temperature dips for about a year or 2 after a volcano because they inject huge amount of sulfate particles into the stratosphere where they can bounce away sunlight and make us cooler. This is the El Nino La Nina pattern, and wherever we're in a El Nino period, which is the red, notice that it gets hotter on average globally. Some places on Earth are hotter, some are colder, but on average the Earth is warmer when we're in El Nino. So some of you, this was the 1998 El Nino, and so it was really popular on Rush Limbaugh and other conservative talk radio. They would say, oh, is it just a hoax because warming has paused? So they cherry-picked this El Nino year, and we didn't have any El Ninos after that, so they said, oh, temperatures have been flat. Well, sure enough, the next El Nino came along, and we're much hotter than we've ever been. So you're going to see these natural ups and downs. If we have a volcano erupt, we'll probably have a cool couple of years. So you have to sort of look beyond that noise and find the overall signal. If you look at what's going on from the natural sources, so here this volcano shows these dips whenever we've had a volcano. You look at volcanoes, you look at solar. So solar goes through the sunspot cycle. Orbit, you see, is barely changing. Orbit changes us over tens of thousands of years, but since 1880 it hasn't been changing much at all. So if you look at all these natural patterns, you need to know them. You need to know the volcanoes to know when temperatures have dipped, but these can't explain the pattern. It's not kernel mustard. If kernel mustard is these natural sources, that's not our culprit. What does explain the warming is these human things that we've done. And what scares me the most about this is that the greenhouse gases we've put in the air have actually caused much more warming than what we've seen overall. Because we've been offsetting some of it with particulate matter. Sometimes air pollution people call it particulate matter. Climate scientists usually call it aerosols. This doesn't mean the spray cans. This means tiny microscopic particles, about 1/millionth of a meter in diameter. And these block away sunlight. These are also the deadliest air pollutants. Okay, worldwide, particulate matter kills about 6 million people. About 3 million people from outdoor air, largely in China, India, parts of the world that are really polluted outdoors. About 3 million people in indoor air, people who are cooking their meals over dung and firewood and things that aren't well ventilated. So we want to get rid of this as well as we can. In the US, we've cut these particulate matter levels by about 70%. China and India and others are eventually want to follow suit and clean up their particulate matter. So eventually, to protect health, we want to get this back up towards 0, and then we're going to start seeing even more of the warming that's caused by the greenhouse gases. So if you look at those effects on a different level, that greenhouse gas is mostly CO2, some from methane, some from CFCs, some from nitrous oxide. Aerosols are particles. The black particles absorb and warm us up, but the other particles reflect away a lot of sunlight. So that's happening there. People interested in the atmospheric chemistry, happy to talk more about that offline with you. With the carbon, where it's been going up has been because we burn fossil fuels, that's what's been really accelerating. Land use has been pretty flat level of emissions. That's been the steady deforestation that's been putting substantial amounts into the air. And whatever we put up must go somewhere. So this much goes into the ocean. This much goes into growing more. Trees are getting bigger right now with the carbon fertilization. And this is what we worry about here, is this is how much has been going into the atmosphere. So that's what's been building up over time. And one way to think about it is like a bathtub. So we've been pouring in these emissions, and the removal processes can only take out so much. So in terms of the overall amounts of what these removal are, CO2 in terms of the overall amount in this bathtub only gets removed about 1% a year. So if we just slowed down this tap, we would still be putting more into our bathtub than this drain could remove. This drain only removes 1%. And so we can't just slow down emissions. We need to bring this down all the way to this level, or we need to open the drain and have things that are pulling more carbon out of the air. Methane's another greenhouse gas. Particulate matter, so those aerosols that are killing us, other air pollution, it's removed faster than once a year. Okay, what we emit is going to rain out, is going to be gone within a month. So if we were to just hypothetically be able to shut down and shut down all the coal and go to solar and wind and everything else right now, all those cooling particles would leave us, but still most of the CO2 would be there warming us for a while. It's going to take decades or centuries for that CO2 to work its way back out, is what makes it such a difficult problem. So when we have, ever since EPA was founded by President Richard Nixon in 1970, they've been able to cut those air pollutants like particulate matter by 73%, even as the economy grows. Okay? So you don't have to have a trade-off between jobs and clean air. We've done that. But all these air pollutants are things that affect us locally. They only last for days or weeks, so when we clean this up, we breathe cleaner air. Carbon dioxide is something that is much more difficult to control. You can't just put a scrubber on it. If you put a scrubber on your car, it would weigh twice as much of your car by the end of the year. Okay, because all the carbon that you burn actually weighs more once you add oxygen onto it and it becomes CO2. And this affects the globe. We'd be fine breathing twice as much CO2, so we don't get the local benefit if we control this. So we haven't controlled CO2 as much. We've controlled the rest. We breathe cleaner air, but we breathe warmer air, is what we've been heading towards. And globally, what the pattern has been is that emissions have kept going up. We signed a Kyoto Protocol in 1997, and actually emissions rose faster than ever. This is when China's emissions really took off. I had been hopeful here, is that I and other people thought maybe we were hitting a plateau. The last couple of years have been very discouraging, that emissions have gone back up for a variety of reasons. And so as a result, CO2 is going up, and if you look at this more closely, it's actually accelerating upwards, the amount of CO2 in the air. And since we're going to look at the US problem, just to look at the US problem we need to solve, in the US, about 45% is from oil, 30% gas, 26% coal. Globally, it's different. Globally, coal is a bigger share, and there's less natural gas use globally. And notice that if we're going to clean things up in the US, we have two big elephants in the room. We have transportation, and we have power plants. Those are the two biggest things we need to go after. We need to go after all of this, but if we want to focus on the two biggest things, it's those. So the causes, let's open it up for a new round of questions. What questions do you have about the causes?
This
Sam?
isn't exactly about cause, but like when I have to argue with deniers, the most common thing they say is like, oh, there was a huge blizzard, there was a big cold streak where it was negative 35 and there was no much. So how do I say you're wrong?
Right. So the question was, you have deniers who don't want to believe the climate science. They see a blizzard. That's usually when our Twitter-in-chief sends out his messages. And you know, how do you say that? And yeah, that's weather. We will always have cold. The weather will change by 30 degrees Celsius between a cold front and a heat wave. But you have to average these together across the world, across many years to see the signal from those. Yeah?
So a lot of these problems, we talked about industrial, about large scale, these companies, but what as consumers can we do to limit our carbon footprint?
What we do to limit our carbon footprint individually. Yeah, so when I talk about solutions, this talk is going to talk more about the big picture, but yeah, the individual picture matters a lot. You can see from this where it's coming from. So the two biggest things that emissions are coming from, where do you have the control? Well, so that's how do you get yourself around. So that's your car, having the most efficient car that you can have, going to electric cars, being thoughtful about how you, the amount of air travel that you do, and then electric power. So getting electric power from cleaner sources, not wasting electricity. Those are the two biggest sources. What doesn't show up on here as clearly is the third biggest part of your personal footprint is what you eat. And so that's embedded in some of the other things. This is a CO2 plot. If you looked at the methane and the nitrous oxide, most of that is coming from agriculture, from excess fertilizer, from livestock, burping and farting. And so, usually beef is about half of our carbon footprint in the food. So really, those three things is what you want to be thinking about in terms of your personal impact on the planet.
In 1969, Paul Ehrlich wrote a book called The Population Bomb.
Right.
And he said at some point in time, we have to level off. The death rate will have to increase. We have to increase the deaths by war and by famine and by disease. Since all of these industrial, those are all caused by people, how much is reducing our global population going to be an impact in getting rid of these causes?
Okay, so a question about Ehrlich. A lot of Ehrlich's claims have really either been discredited or a lot of people have moved away from some of the points that he made. Very, very controversial claims, so I don't want to get into all that debate right now. But in terms of population, I don't have the slide here, but in the directed study, one thing that I've had of a way of thinking about things is that how much we emit as a planet is basically how many people are there, times how wealthy is each person, times how much do we have to emit to get $1 of economy. And so population is one of those multipliers. The higher population gets, the higher emissions get, or we need to find ways that each person, or as people get wealthier, that we can have more people and be wealthier. If that's going to happen, and no one wants to run on a campaign platform of making your country poor, so if we want to be wealthy and we're not going to drastically cut population anytime soon, that means we need to move even faster on efficiency, on renewables, on things that cut down and use less energy per person per dollar of economy. So the impacts. There's a lot of cool things that can happen with satellites that can tell us what happens. So this is just one example of many. NASA has the GRACE satellites. These have been decommissioned, but they have a new one that's supposed to launch soon, where they sense how far apart they are, and that tells them the gravitational force that's pulling them, and can tell very slight variations in it. And so with that, they can see how much mass there is on Antarctica, how much mass there is on Greenland, and it's very alarming. So Antarctica had been pretty stable, but just in the past decade has started shedding lots of ice. It started melting lots of ice. The bigger loss so far has been from Greenland, and that's been a steady decline, is that the mass of Greenland has been declining by 286 billion tons every year is melting off of Greenland. So you see it going up and down, so it adds in the winter and it melts in the summer. But overall, we keep melting much more in the summer than we're adding back in the winter. And that, as well as thermal expansion of water, is causing sea level to go up about 3 millimeters a year. If these are coastlines now, we're Texas and Louisiana and Mississippi delegates. All right. So this is what the coastlines look like now. If you add 2 meters of sea level rise, which probably we won't get to until sometime in the 2100s, okay, you have a lot of areas that would start being underwater, especially Louisiana, and I know probably not many of you from these other places, but over 10 million people living in Shanghai, some of these other coastal Asian cities. If you add a 4-meter storm surge, okay, so it's not so much that you just slowly have the ocean creeping up, it's that it's slowly creeping up, and that's being added on top of stronger storms and stronger rains. And so then, when a storm comes through, then you're much more vulnerable to that storm. Okay, so for the Texas, the Oklahoma, and the Kansas delegates, this is what came from I don't know why how to get rid of this in the bottom, but this comes from National Climate Assessment. It got released last year, and to the Trump administration's credit, they did not alter any of this politically. What they did is they released this the day after Thanksgiving, so no one would pay attention. Unfortunately for them, nothing else was in the news. This was on every front page of the newspaper. Great set of 30 chapters there that goes through all the projected impacts. This is about the scenario that we're on. This is sort of the 3 degrees Celsius sort of case. And this is how many more 100-degree days you would have here. And sorry that you can't see the bottom of the slide, than just recently, than 1976 to 2005. And so you see about 30 more days, 30 to 40 more days. Dallas, where I grew up, is about 40 more days every year where it's going to be above 100 degrees Fahrenheit. Okay, so you're going to get to where you almost have more days above 100 than you have days of summer. You're going to have fall and spring days occasionally, which are going to top 100 degrees. If we don't follow what we promised in Paris, if the world doesn't follow what they promised in Paris, we could be just baking hot. It's already gotten wetter, so this is how much wetter it's gotten from 1901 to 2016. This is specifically how wet are the 1 percentile, or the 1% rainiest days of the year. Okay, so overall rain is only going up slightly, but when you warm the planet, as someone who's lived in Texas and lived in Boston, when you're in a more tropical setting, the rain comes down, rains like cats and dogs, comes down in big sheets, big thunderstorms, versus a Boston drizzle. Okay, and so as we get warmer, not only do we evaporate more and what goes up comes down, but it comes down all at once, and then we have droughts in between. And so these wettest 1% of the time, in the Midwest, so any Ohio or Illinois delegates, your wettest days are already 42% wetter than they were in the beginning of the 1900s. And this projects, again, this is the more likely scenario. This shows that beyond this, we're probably going to get another 20-something% wetter on the rainiest days. So if you think about when the Mississippi River in Nebraska had some terrible flooding this year, all that, each year is going to be different. Some are going to be wet, some are going to be dry, but on average, your 1% rainiest days of the year are going to get a lot more intense. This is the one that hit home for me. This is the most rainfall that's ever fallen anywhere in the continental United States within a week's time. 50 inches of rain dumped down on my hometown of Houston. Within a few days, there's Houston right there, carrying into Louisiana. And that storm, you definitely have had hurricanes forever, but the reason why it was able to hit record level was in part because the ocean, the Gulf of Mexico, was unusually hot. It only needs 28 degrees, sorry that this is cut off, but 28 is right there in the white. You see we were well 3 or 4 degrees warmer than that here. The storm actually, once it came over, it pulled so much heat from the ocean that it cooled things off where the storm had been, but it left behind 40 to 50 inches of rain. There's still studies coming out, but the first 3 or 4 studies that have come out estimate anywhere from 15 to 35% more rain fell because of climate change. Okay, so you could have had storms before, but that extra warm ocean, the extra warm air that can hold more water, had bigger effects there. So questions on the impact? Yeah.
Do you know how much of an impact it will have on islands like the land?
So the question was how much impact will it have on islands. Hawaii is relatively well off for Hawaii delegates, because Hawaii is pretty mountainous. Is that it's the sea level, it gets above sea level pretty quickly. What is much more of a concern and is countries like the Maldives, where most of their population is within 1 or 2 meters of sea level. The Bahamas, most of that, much of the Caribbean islands are only a couple meters high. And so you're really seeing existential threats, and a lot of projections show we're likely to have a lot of climate refugees soon. If you think about, refugees, how that's affected Europe, how that's affected the U.S., it's really unpredictable. How is that going to change things when you have countries that really can't survive anymore, that don't have the wealth to be able to build the systems like the Netherlands has built? If you're a wealthy country, you can find ways to adapt. If you're all in a low island and you don't have the wealth, it's going to be very difficult. Yeah.
How do you feel that oscillations like ENSO and the Pacific Decadal Oscillation and their phases of ENSO being hot and wet and La Nina being dry and cold will reflect global warming in relation to droughts like the ones seen in 2012 and 2018 in the Midwest?
Okay. So the question is about El Nino and La Nina and other oscillations, how will that affect things? Like I showed in that variability plot, when we have an El Nino, some places get hotter and drier, some places get colder and wetter. It's not consistently, but if you average over the globe, El Ninos are hotter, La Ninas are colder. But that's one of the really most uncertain areas of climate science, is we don't know whether a warmer planet is going to have more of one type of the oscillation or another. There's a lot of debate in the scientific community there. Yeah?
You said the reasons this happening is because we're not taking the CO2 out of the atmosphere. Why is that? Are we just unable to match our speed, or are we just not have the financial
Yeah, so I'll get that in a minute. But we're emitting 37 billion tons a year. So we're emitting about, 7 billion people on the planet. We're emitting 5 tons per person per year. Okay, so each of us weighs, less than a tenth of a ton? But we're emitting 5 tons on average. Americans are emitting way more than that. We're emitting many times our weight each year in CO2. And so, yeah, the trees are taking it up because the CO2 is far less in trees. The oceans are taking some up, but we don't have any man-made that we're just experimenting with ways to man-made pull it out of the air. And even if we could, 37 billion tons, that's a lot. I don't even know how to fathom how much that is. Every person on Earth would need to have the equivalent of something sucking 5 tons a year out of the air. So we have to get those emissions way, way down, and then you start thinking about sinks to pull down that. Yeah.
So we see a lot of movements now for people wanting to ban plastic straws and plastic bags. How much do you think those movements will end up having an effect in mitigating the impacts of pollution?
The question was about movements to ban plastic straws and other plastics. That's a pretty small share of the warming. It's important for waste and for the trash in the Pacific. It's every little bit helps, but that's not. I showed where the biggest things are: transportation, electric power. Those are the biggest things to go after. Yeah.
So I noticed you didn't talk about tornadoes, and I've always been really curious about tornadoes because I know on one hand stability,
Yeah.
on the other hand just you play further on.
Yeah. So that's one of those things like El Nino where we don't tornado. It was us about tornadoes. The science isn't clear about how tornadoes really work. Yeah.
Why does a climate getting warmer necessarily make it less stable?
So the question is, why does a climate getting warmer necessarily make it less stable? I would not say that it makes it less stable, especially because the Arctic is warming faster than the tropics. So you actually have a more stable temperature gradient. So in some cases you'll have less strong winds, you'll have a less strong jet stream, although that means that the jet stream will more often get blocked, and so you're going to have these blocking patterns that can actually hold, like a polar vortex in place, or that could hold a heat wave in place. So it's less stable. Stable isn't the word that I would necessarily use, but the warmer it gets, the more energy in the atmosphere and the more moisture. You evaporate more water, so you're going to have more go up, you're going to have more go down, and like I gave that tropics versus Boston drizzle analogy, it's going to come in more. The hotter you get, the more it tends to come in droughts and in really wet times. So that gets stronger, and then heat adds to the strength of things like hurricanes, because they're basically a heat engine that feeds off of the heat of the ocean. That's thermal energy turns into kinetic energy. And so in those particular ways, it's going to be less stable, but I wouldn't call it just generically that it's going to be less stable. Yeah.
So, with the maps of what cities have been doing water,
Mhm.
do you think that just the threat of losing it in New York City, being underwater, is enough to mobilize people to make more drastic changes than what we've been doing so far, or do you think it's going to take some level of disaster actually happening before people?
Yeah, the question is, with all these events happening, is that mobilizing public opinion, public activism? I have that on a slide later. That's something that I've actually been looking at a lot in research, and I've talked to. There's some great groups at Yale and at George Mason University where they survey 2 or 3 times a year and get opinion. And so what you've seen is not only is acceptance of climate science going up. People say it is warming, it is human cause. More people accept that than ever before. But you're seeing what's really gone up the most is people saying this is a problem here and now. This isn't polar bears and for my grandchildren, this is more people than ever. What's really spiked the most is people saying my community, me, my family, or people that I know are being affected by climate change now. And so I think that's where it's not among all voters, but among certain voters, that's what's rocketed it to not just one of the 10 or 15 concerns they have when they go to vote, but you have more and more people saying, this is affecting me now, and so this is one of my top 5 priorities. And if you look at your generation, if you look at when they survey 18 to 24-year-olds, the youngest voters, they rank climate change as high as any other topic. And so I think you're going to see growing activism, growing interest, and if your generation starts voting more than, unfortunately, young people haven't voted in the past, I think you could have more clout. And it's really becoming a generational thing, people seeing this as something that to realize. Yeah?
How much of world population is within 1 or 2 meters of the
I don't know the exact answer, but a lot.
I mean, I've heard big numbers.
Yeah, and definitely in Asia is where the most concerned. There are poor countries in Asia that have a hard time with that. Yeah.
What do you think, how effective is population control would be, like limiting how many kids people have?
Yeah. The question was how effective would population control be? I'm not going to touch that question. I think I addressed it a little bit in saying, population matters. But, a lot of things going on. So moving to the solutions, how am I doing on time? Am I sort of at the halfway point, or where am I?
Half an hour.
Half an hour left?
Yep.
So this is the sort of premise that I'm going with, and I'm just 3 chapters in, really just working on this component in terms of what I write. But the argument that I'm going to make, so hopefully move from, sorry if it's been a bit of gloom and doom so far, but so move to what can we do about it. And what I argue that we need to do about it is that we've been gridlocked because we haven't been able to grasp these 3 keys. And yet these 3 keys are actually closer to our reach than ever before, but we don't know if we're going to grasp any of them, and we need to grasp all 3 or we won't break out of this room. And it can be the analogy in the book to when my daughter convinced me and her grandmother to take her to an escape room. And it was actually locked by a set of locks, and only once we found all the keys could we get out. We actually, just after the timer went off, so we failed, did we find the final key to open this? Ended up there was one more door. We still had to get one more code to be able to get out of the escape room. So we totally failed, but this idea of multiple things locking us in and then going beyond. And argue that it's these 3 things that we need. And so to focus on what I mean by diplomacy first, what diplomacy is needed for is, well, I'll talk about it in a minute what it is. So where diplomacy is most focused around now is the Paris Agreement. And that was really what transformed where we are in diplomacy, in that it set 2 targets. So probably what you heard in the headlines the most is that they agreed that we're going to aim for somewhere between 1.5 and what it said well below 2 degrees Celsius of warming above pre-industrial levels. Okay, and we're already at 1 or 1.1, so that really doesn't give us a whole lot of room left if we're going to really meet this target. It also had an emissions target that people are less aware of. That's the Article 4 part of the treaty. And that said that we're going to aim for net zero as a planet. We're going to aim to balance the sources and the sinks, which is what we have to do if we're going to stabilize the climate, in the second half of this century. Didn't specify exactly when, but that's the aim globally. This is what I actually think is more exciting. Okay, this is the overall goal, but it doesn't tell us what we need to do on emissions. This is like saying I want to lose 20 pounds. Okay, but I don't know how I'm going to lose 20 pounds. This is like my weight loss plan. This is saying I need to get my calorie intake in balance with my calories that I burn with exercise. So this is the more actionable thing. And here, the way we're going to do it is going to be radically different than the way treaties worked before. Is the way Kyoto Protocol works, and I've actually had really the excitement of interviewing some of the U.S. climate negotiators who were in the room where it happened. They were up till 2 a.m. at night, negotiating behind the scenes. Only the wealthiest countries in the world were there, and they said, U.S. agrees to do this, EU is going to do this, Japan will do this, and they all got together and mandated it, but it didn't work, because Congress never said, we give authority to a State Department diplomat or to Vice President Al Gore to make that deal. And so the U.S. dropped out. Now what it is each country gets to decide for themselves what happens. And instead of having just the wealthy people get together in the room and leave the developing countries out and say, China, you don't have to do anything, we say every country has to set their own contribution. We don't say what that will be. Every country chooses for themselves. And so together, so this is a bottom-up rather than a top-down approach. So I think there's a lot of merit to it, but there's also a lot of problems that just because it's voluntary and because it's sort of climate controlled by peer pressure, so far people haven't stepped up enough. And so what we saw in the directed study was what happens when you have just people making a pledge without negotiating yet, without seeing where they'll go, is that they've made pledges that would put us on this path. This is the emissions path. So emissions would keep going up and be like this. So we're not on this 4-degree world anymore, but the best estimates of what countries have pledged so far, if they follow through, is about 3 degrees Celsius of warming. If we want to be consistent with 1.5 or 2 degrees, we need to get to net zero emissions in your lifetimes. We need to get to net zero emissions within the next 50 years or so. So these are the emissions paths that would be consistent. If we're serious about the temperature target, if we're serious about losing 20 pounds, we need to have a diet, we need to have carbon emissions that look like this. Right now, what countries are pledging looks like this. What they're actually doing isn't as good as their pledges, looks like this. So this is what the United Nations each year issues what's called an emissions gap report. And that shows this yawning divide between what we say we want to do temperature-wise and what each country is pledged to do. This is what the US pledged to do. So the US, our emissions actually peaked around 2007, then there was a recession, but then natural gas replaced coal, solar and wind are starting to replace natural gas. So we had emissions have been coming down, and what President Obama pledged in Paris was to aim for 26 to 28% reduction from 2005 to 2025, and they said we're going to aim for an 80% reduction by 2050. Okay? He didn't really specify or commit to this, but he picked this to be on a path here. It's been amazing to see just in the past 2 years how politics have changed. Okay, so for my home state, Beto O'Rourke issued a climate plan where he said he was going to get to net zero by 2050, and he got condemned by the Sunrise Movement, saying you're condemning us to death because we don't have until 2050 to get to net zero. So what, people were saying Obama is crazy ambitious to aim for 80% by 2050. Now you're hearing a lot of presidential candidates saying somewhere in here they want to get all the way to zero. Okay, so interesting dynamics of how that changed, but at the same time, what you've seen is that emissions have flatlined. With the progress we've made, emissions actually went up last year for the first time in several years. So we have this yawning divide between what's actually happening on the ground and what the most ambitious political things that are being pushed. What's going to make this difficult? What makes it difficult is that the benefits are global, so we all benefit from a world that isn't racing up towards hotter temperatures. The impacts are tens of trillions of dollars. Okay, a number of books that have showed all these impacts, so we would all be better off if we did it. But when it's a common area, tragedy of commons, I can go into more offline because I know it's a lot to cover, says that you don't do as much when it's a shared area as when you enjoy the benefits yourself. But this is something where all the costs are local. You have to put in the devices yourself, but the benefits are shared. And the shared benefits are a public good. We can't keep other people from enjoying cleaner air, cleaner water, a cooler climate. And so there's a free rider problem, is that everyone wants to get a free ride along other people doing their thing. And there is no central authority. Yes, there's the United Nations, but that's just a coalition of the willing. No one's going to give up their Senate or their Politburo or their Parliament's authority to a United Nations. And so the question is, how do we have cooperation when there's not a central thing? When there's not some mandate, there's not a UN Secretary General, he doesn't have any power to say what you have to do, what your country has to do, what your country has to do. How do you have cooperation evolve without that central authority? And what we need it to do is we need it to be able to do two things. We need diplomacy that impels us to act and impels other countries to act, and do so in durable ways. That makes it in our self-interest, because each country is only going to do what's in its own self-interest. We're unfortunately not a very altruistic world. So how do we make it in our self-interest to do action and keep it durable even as the politics change? Okay, so if a president comes in the next election and says we're going to go 100% by 2040, and then another administration comes along and reverses it, that's not durable. How do we make it not swing with the political pendulum? And how do we leverage US action into action abroad? It's the biggest argument, even after people start accepting the climate science, is they say, well, why should we act if China's not going to act? Why should we act if India is not going to act? And so how do we take it so that if we cut more, other countries do too? That's what we need to try to aim for with diplomacy. And so people who've studied it, there's this terrific book, Robert Axelrod came out with it from some game theory experiments that he did with an iterated prisoner's dilemma. I hear that you've had either a lecture or a directed study about game theory. What he found from his experiments is that there are 4 things that are needed if you want cooperation to happen when there's not a central authority. If you want it to arise organically for people to cooperate with each other, they need to do 4 things. They need to start out being nice. So you need to start out making that leap of faith and start taking action even before you know everyone else is doing the same. Otherwise, everyone's going to be like, oh, well, China's doing it. You'll just always be able to point blame and you'll never get anywhere. The other thing is, don't just follow the golden rule. Don't just be nice to everyone. Don't just do unto others what you want them to do on you. I would want you to clean up your stuff and leave me alone and let me keep being dirty. But that's not the way to go. That eye for an eye is actually a better way to get cooperation. It might not be the religious or moral way to go, but if you want this to happen in the real world with selfish countries, you need to retaliate when countries don't do something. And so when the US backs out of the Kyoto Protocol and now is about to back out of the Paris Agreement, we haven't faced any consequences. Okay? Europe, furrows their eyebrows and, says, y'all shouldn't have backed out. But what penalties have we had for doing that? So there hasn't been any reason that we should be doing more. We need to be forgiving. So if you're an island nation, it would be easy just to say, well, y'all should just pay us, hundreds of billions in reparations. If the Senate isn't going to be willing to pay $100 billion in reparations, so that could stall things if you don't forgive what's happened before. And you need to be clear. If you know what each person's doing, what their strategy is, you're more likely to be able to cooperate. You need ways to verify what's happening. You need to make pledges that are conditional. So say, I'll cut emissions 20%, but if you're willing to have your country do even more, I'll up my ambition to 30%. So make it where that's way you can leverage what you do, and if you do more, you make sure that others do more as well. So all this could happen within how we do the Paris Agreement globally, but there are problems with the Paris Agreement being global. Because Paris Agreement and United Nations things happen by consensus. And so Saudi Arabia wants to sell more oil, they can block any global agreement. So I argue that we need to do more than just that. We need to make carrots and sticks, so there are reasons to do it, so it becomes our self-interest. One of the best ideas, this has been pushed by William Nordhaus, anyone here when he won the Nobel Prize in Economics last year. So he won it for his ideas about how to address climate change. So really a telling thing that climate change is what's winning Nobel Prize in Economics. One of his ideas, and it's shared by others, is that we need climate clubs. Let's have coalitions of the willing. Let's have coalitions of the ambitious. Let's have them get together and say, hey, we're going to give each other most favored nation status. We're going to wipe out trade tariffs. We're going to share solar and other technologies between each other if you join our club. So there's a reason to do things. It's not just furrowing the eyebrows, but it's actually giving advantage to want to stay in it. That makes it durable because you're not going to want to back out of a deal like that. You can partner on research, you can give funds, and you can go sector by sector. So this is too big of a problem in some ways globally, so maybe you just need to address the aviation problem. Maybe you need to address shipping on its own. Maybe you need electric cars to be addressed in their own way, rather than seeing this all as a global thing. Questions about the diplomacy side of things? Yeah.
Why is it that it's such a political stance to believe in climate change? Is it just because of the coal and oil industry, or is it people?
It's a great question, because the U.S. is the only country where one major political party has had its official position to deny the climate science. There's no other country in the world where it's so entrenched in a single political party. It had its roots in oil companies and coal companies that pushed a lot of climate denialism. They had great scientists in-house, they knew what was going on, but just like the tobacco companies, they pushed it. A great book, Merchants of Doubt, that shows how they did that. They've changed away from that. Oil companies are now asking, hey, tax us, put a carbon tax on us. They're now pushing climate science. They accept the science now, but somehow it became entrenched in political ideology, and it became a red tribe, blue tribe thing, where even though the people who had been pushing denialism before have moved on from that, somehow it became entrenched, and it just hasn't worked its way out yet. Hopefully new generations are going to push that out. Yeah?
Why are developing nations often not involved in discussion about climate
Yeah, so why are developing countries not often involved in discussion? That really had its origins in the Rio Earth Summit in 1992, which was the first time the world got together for a climate treaty, and they decided that the rich countries had to act first because at the time the rich countries had almost all the emissions and had better capacity to do it. So they said, we're going to act first, we're going to let the poorer countries come later. And it's been over time where some of what had been poorer countries like China have become such big emitters that it's become more urgent to have them involved too. Yeah.
What do you think will happen in the COP in Chile this year?
The COP in Chile this year. The question, so there's annual talks happening. I don't think this year is going to do a lot. What I think is going to be important is the London talks that are going to happen next year. So the London talks are going to happen a couple weeks after the US presidential election. And a week after the US, with Trump's announcement, that's when the US is eligible to drop out of the Paris Agreement. And so you're going to have either Trump re-elected or you're going to have a new president elected. And I think what's going to be really, I don't know what's going to happen in the election, but if there is a new president elected, what I think is, the $10 billion question is, what is he going or she going to say with the world? It won't be the president yet, but how will they convey that perhaps Trump will pull us out of the Paris Agreement for a month or two, but what's happening? And London is actually the big one where we start looking towards the 5-year stock takes and really make the plans for the next round. So that's what I would look for in this. Okay, so moving on to technologies. What we need is, technology is needed to make this more affordable. Because we only act if we know other countries will act, that's what diplomacy is for, but we only act if it's affordable. We only act if it's in our self-interest, or if it's at least not wildly not in our self-interest. So to do that, we need these things. This is Obama administration's plan of how they were going to get 80%. They knew the economy would grow over 50 years, so they said we need to use efficiency, we need clean electricity, and we need electrification and low carbon fuels. That's how we clean up the energy sector. Then we need to have more removal. And then we need to clean up other greenhouse gases. So starting with efficiency, this is the best thing we can do, is we're not doing all those things on the left. All those things that are megawatts that would actually pay for themselves many times over. Okay, why are all these bulbs not LED? Okay, I have no idea. They would pay for themselves within a few months' time. We're not doing all the things that could save energy and save us money right away. Okay. Vehicles can be made more efficient. So vehicles have been getting a lot more efficient, but you see this is the US curve, has been behind the rest of the world. Trump administration has decided to freeze all progress, so instead of going up, wants to freeze it at the 2020 levels. Okay, so we do a lot more on efficiency. Clean electricity is the next biggest chunk in this cascade downwards. What's encouraging here is that wind and solar is becoming the cheapest ways to generate electricity. Wind costs have come down by 2/3, solar costs have come down 88% in just less than 10 years' time. So when I started teaching my energy class, the question was, how can we afford, is it worth paying a few times more for solar electricity? Is that worth the health savings? Now these are the absolute cheapest ways to generate electricity. And this shows that here is that this is solar farms, this is wind farms. They are cheaper than, even cheaper than gas, way cheaper than nuclear, way cheaper. Coal isn't even on here, no one's building coal plants in the United States anymore. So it's the cheapest way to go. And so it's only, this is if you build new. So it's hard to displace old plants that have already paid for themselves, that have been allowed to emit all they want. But if you were to build new electricity sources today, you would want to build wind and solar for the most part. Solar technologies are getting better, so this is the efficiency that's coming up. And one thing to look for is these yellow dots is something that didn't exist until here, is this is solar perovskites. And what's exciting about those, and one of the many labs that I got to tour in researching this book was the solar perovskite lab at National Renewable Energy Lab in Colorado. And they're designing these that can actually be printed just like you print newsprint. So even though silicon cells are getting cheaper than ever before, and a lot of people say that's good enough, other people like Varun Sivaram wrote a terrific book, Taming the Sun, where he argues that this lets you produce it 10 times as fast as you can make a panel. And this lets it be flexible. You can put it on your car roof to recharge your car battery. You could put it on clothing, backpacks, all sorts of things. So this isn't quite at commercial scale, but there's a British company wanting to start the first demonstration next year. The guy I talked with at Inrail says he's hoping for 1 or 2 cents a kilowatt hour electricity from these perovskites, because you don't need all that aluminum, you don't need all those rigid panels. The question is, how do you balance it? So just on a raw kilowatt hours basis, wind and solar are now the absolute cheapest way to go. But we want to keep the lights on all the time, even when it's not sunny and even when it's not windy. So that means we need to link together wind and solar, or we need things to balance with them that aren't dirty fossil fuels. So either we need to capture the carbon from fossil fuels, or we need to go with cleaner things that generate all the time, or we need things that can respond really quickly to ups and downs. This was a paper that I did with an undergraduate researcher, and so just like Dr. Katie pointed out yesterday, look for ways to do undergraduate research. So Joanna Sucerowicz was the first author on this paper, and showed that in Texas, for example, it's not sunny all the time, it's not windy in West Texas all the time, it's not windy in South Texas all the time, but if you look across 24 hours of the day, you're always getting power from one of those sources. So if you link together solar and wind farms, you can cover more of the day, and you don't need as many batteries, you don't need as many nuclear plants, you don't need as many other things. It won't get you all the way, but it can get you a lot of the way. And so we have these sunny parts of the country, we have these windy parts of the country. Texas is lucky that we're both. If we link together these grids, we could do a lot more. Another way we could do things is nuclear and carbon capture. Unfortunately, the two most recent plants have had a lot of trouble, have been $10 billion, or $5 or so billion over budget. Carbon capture, a lot of the efforts have failed. These two were both abandoned. This one was successful, but it's only capturing a small fraction of its emissions. And this is the one that I'm hopeful for, that's been built right half an hour away from Rice, that has a lot of promise if it comes through. A lot of battery and storage things that can be done. Moving along to the electrification. So if we are efficient, that means we don't need as many solar farms and wind farms. If we have clean electricity, that means we have less coming out of power plants. And if we have a clean electric grid, then it makes sense to electrify our cars, to electrify our buildings, to move away from natural gas to electric heat pumps. Okay? All these things don't make sense if it's coal powering the electricity going into the car, but they do make sense once we, at the same time as we're cleaning this up, we need to electrify things, because there's only so clean you can make a gasoline car. There's only so clean you can make a natural gas furnace, but you need electrification and you need low carbon fuels for what you can't electrify. So the bottom is what's already electrified, the top is what's not electrified yet, and so you see the biggest thing that's not electrified is transportation, and there are a lot of things in industrial, okay, things like arc heating and so on, that could eventually be electrified. So this is a study of what could be electrified someday, and as Dr. Rick Walker pointed out in his seminar, there are more and more options for models that are coming out in the next few years. So probably a lot of you won't be buying cars in college, but by the time you graduate from college, there will be a lot more electric cars for you to choose from. And the Crazy Wild Environmental Green Group, UBS, so the investment bank, did this study. They broke down all the pieces of an electric car and I think it was actually a Chevy Bolt. I think it was the car that you were driving here yesterday. They found that by the 2020s, it's going to be as cheap to have an electric car as it will be to have a gasoline car. Not just total cost of ownership, not just over the 10 years, but actually they think it could get to where it's as cheap to manufacture a battery car as a gasoline car. Because yeah, the battery is expensive, but you don't, 10 minutes, okay? But you don't need to make that engine anymore. You don't need to make the catalytic converter anymore, because you're not making the pollution in the first place. And so you have some costs that go up, some that go down, but they think that by the mid-2020s, we can get to where it's just as cheap to buy an electric car at the dealership as it is a gasoline car. And at that point, you're going to save money by not buying all that gasoline. It'll become a no-brainer. If we build the charging infrastructure, it'll be a no-brainer. And when you do that, you actually make it easier to go to wind and solar. Because, so these things all feed back on each other. If we have electric cars, then when it's sunny and windy, we can charge up our cars and load up the battery. And then when it's the wind and sun die down, we could potentially discharge, or we could at least not be charging our cars at those times. So key thing is that all three of these things, efficiency, electrification, and clean electricity, all actually make each other easier to do. And then we might need some low carbon fuels for what we can't electrify. Okay, so that's how these three pieces all make each other possible. And notice that's the most reduction in emissions. That's where the biggest comes from. But that's not enough. We need to pull some out of the atmosphere. One way to do it is with biochar. So that's where we pyrolyze biomass and we put it in the soil. They found that Incans actually did this. If you look at Inca sites, there's actually layers of char because they realized that that made their soils more productive. So you get a triple win. You get energy here, you get char that makes your soil more productive, and the char locks up carbon much longer than it would in soil normally. Normally leaves or plants decay and give their carbon right back to the air. This char, we're still seeing it from Incan times, so it's going to last for millennia longer. Okay? This is another way that we might capture carbon from bioenergy. And then this has been a lot in the news of ways that you can actually directly suck carbon out of the air. This is the coolest whiz-bang stuff. This, for now, is more expensive than any of those other ways, and it doesn't help agriculture, and it needs more building. So this gets, I would love for them to succeed. It's not quite, I think, as good as some of the other options. And then we need to do things to clean up the other greenhouse gases as well. So questions about the technologies? Yeah.
So as you like you said predictions about like electric cars and things, we talk about like the batteries in electric cars and using things like lithium, like they've been like thinking about like the environmental impact of like mining for lithium.
Yeah. So the question is, with electric cars having more batteries, they're going to need lithium, they're going to need cobalt, they're going to need some rare earth metals, environmental impact. So that's going to be a huge thing that we're going to need to figure how do we. So some of you interested in electrical and mechanical engineering, how can you design them that need less? Those of you environmental engineering, how can we mine for them and transport them in ways that are less damaging? So all these things are important. At the same time, we're going to need less of some other things. Okay, we're not going to be fracking and drilling and mining for as many fossil fuels. We're not going to need as much platinum for catalytic converters because we won't be making the exhaust in the first place. So you'll need more of some things, you'll need less of others. No one has found anything that is a fundamental, we can't solve this problem, but there's going to be dozens and dozens or hundreds and hundreds of problems for you all to solve as the world changes so rapidly. Yeah.
In the production of livestock and like milk cows and egg chickens, do you think in the next coming years environmental engineers will be able to come up with solutions that are sustainable, or do you think it's completely impossible to raise livestock anymore?
So the question is, can livestock be made more sustainable? And we are one of the hundreds of groups looking at things like that. One of the most important things is, are there ways that we can use less fertilizer and still grow as many crops? Because most livestock is grain-fed, and so a lot of the impacts come from over-fertilizing our crops, creating nitrous oxide. There are supplements that can be fed to livestock to make them burp and fart less methane. And so, yeah, it will never be as green as being vegan, but there are ways to make it more sustainable.
Could you elaborate on using like potential energy like water storage and battery storage and relative efficiencies?
Yeah, so the question is water storage versus battery storage. How many know what the main way is of making storage in this country right now? So it's actually the water storage by a long shot. It's you pump water up the hill to a reservoir up here, and then you send it back down when you want to get electricity. Batteries, so that's what we've done. But a lot of places you can't have two reservoirs, so batteries is more widely deployed. Lithium batteries are what's being done now. What I think is the biggest, one of the biggest needs to happen later. You look back at what was that? This slide. So that's the pumped hydro that you were talking about. So lithium-ion batteries are great for these short-term periods, minutes. What we need though is hours and days. If we're going to have a really wind and solar-based grid, how is New England going to get through the winter when it needs lots and lots of heat that we might want to electrify, but it's not just dark overnight, but it's dark for days. So I think we might even need new technology. We might need things like flow batteries and new designs that are able to get more multi-day storage. It could be important. So lithium ions is what a lot of people are investing in right now, but we probably need some technology. 5 minutes? And then when it comes to policies, we're on the final key. Lots of things being discussed right now. If you talk to an economist, the most efficient way to do things is to put a price on carbon. Okay? So what we have to pay for, we do less of. And so that can be done with a tax, and I've interviewed some of the people, including Secretary of State James Baker, who have said that should be dividended back. Other people have different ways they want to use the money. There are cap and trade ways of doing things. Definitely happy to talk offline, but limited on time. The Green New Deal is still, the resolution that was issued didn't have a lot of detail, but what it's saying is, okay, maybe we should price carbon, but that doesn't inspire people. That doesn't deal with communities that might be hurt as we move away from coal mining and those communities get hit. That doesn't affect the communities that are most affected by health. That doesn't ensure that we have good jobs as these jobs transition. And so the Green New Deal, whether you agree with it or not, the innovation there was, let's not treat this as a wonky economics problem. Let's inspire people by making this a package of moving towards a more equitable, fair, and emphasize the jobs, emphasize what we want, as well as just the climate side. Clean electricity standards are what's being done most in states right now, is states are requiring 2050, and now you've had, I think, 5 states that are banning 100% clean electricity by around 2045. So you're having more and more. Economists don't like this because that's a mandate. That's telling you what you have to do. But taxes aren't popular, whereas clean electricity is as popular as apple pie. Okay, so this is what can get passed. These haven't been passed nearly as much. You can give incentives, so there's tax credits that get paid to do carbon capture. There's no reason to capture carbon unless you get paid to do it. Okay? There's no incentive unless there's some money for it. We need research and development. We need investments in key infrastructure. This is controversial, so I shouldn't say need, because these are all options. I'm not saying we need any one of these, but one thing that gets said is that we should restrict fossil infrastructure. Controversial, but if that infrastructure is going to be there for 30 or 40 years, and we need to be at net zero in 2050, is that consistent with building new fossil power plants? Some are outright bans and regulations, and even the most controversial is litigation. And I think one thing you see of why oil and gas companies are pushing for carbon taxes and stopping their denialism now is they don't want to go the way of tobacco companies. They don't want to go the way of Purdue Pharmaceuticals, okay, which is about to be bankrupted because they're responsible for the opioid epidemic being sued in court. They'd rather pay a bit, like paying tax on cigarettes, rather than being sued out of business, whether in the United States or elsewhere. The optimism, as I said earlier in response to the question, public opinion is an all-time high and more urgency than ever, especially in your generation. Activism is an all-time high, both on the left, things like the Sunrise Movement, very progressive movement, and on the right, or at least the center-right groups like Republican. They're trying to find ways to get Republicans on board, and the Citizens Climate Lobby that's intentionally centrist and bipartisan. States, cities, and corporate are all doing way more than ever before. California and New York have probably the most aggressive climate policies in the world. So if those become laboratories of innovation that get done elsewhere in the US or world, it'll become huge. Oil and gas companies are changing their ways. Coal companies aren't, but oil and gas companies are. And so lots of reasons for optimism. And then I'll conclude with just showing how these tie together, is that if we have policy, we can leverage the action that we're doing. Or sorry, if we have diplomacy, we can make ways that our action gets leveraged abroad. And by having policy, we have clout to actually push other countries to do something. If we're not doing something here, we can't do diplomacy to say others should do more. By having these two together, diplomacy can help with technology collaborations. Technology can make it more affordable for the poor countries of the world to do more. Technology can allow policy to be more ambitious. When we have policy, regulation breeds innovation. So every time there's been a regulation that says you have to have a cleaner technology, industry always says it's going to cost this much, EPA says it's going to cost this much, real costs are here. Once you actually have to do it, companies find ways to profit, find ways to make money at it. And by doing it in the US, we can make it where it can go global and make it where those things, if we do all those things with those 3 keys, there's no way that the world is going to do anything other than cut its emissions as well, because they're just going to make it, same incentive to do more globally. So thank you for your time. If you don't believe any of my first stuff with the climate science, and you think that we're doing all these 3 keys for nothing, then you'll have to put up with these consequences if it was all a big hoax: energy independence, livable cities, green jobs, renewables, and so on. Yeah.